Letter B. We had this question also. In what two ways is the direction indicated on the picture? Two ways, yes, John.
Actually, I looked it up. So.
Say hi. Say hi. Correct. The plus or minus gives us the direction, and the way the arrows are pointing tells us which way the thing's moving.
Want to say hi, Kim?
Okay, letter C is asking not in general
Letter
about
C.
this particular picture. It sounds almost like a repeat. In this particular picture, what does the length of each arrow tell you about the motion of the object at that particular depth or position? So in this particular picture, what do these arrows tell us?
It's starting slow and getting faster.
Starting slow and getting faster. It's speeding up. And letter D, if you were to make a position versus time graph for this motion, how would the trend line
Say hi.
look?
Say hi. Angel, say hi.
Makes sense.
Put the clothes away.
What would position time graph look like? It's been a while since we talked about this, but if it's speeding up, there's something that's going to happen to the position time graph. We haven't spent much time talking about it, but we have talked about it. What's going to happen? The line's going to get steeper. Now, so let's go ahead and write that. Line will get steeper. There's a couple different ways I can draw the line getting steeper, but only one of them works for this particular picture. Somebody tell me which way this thing is moving. It's moving in the negative direction. So the line's going to get steeper
Let's find out.
in the negative direction. Can anybody
Hey, you're
move their hand in that direction? Which
You're
way is
spinning.
that going to be if it gets steeper and negative? Reading from
would
left to right.
get slower.
Okay, you just got it, Church just got it?
Yeah.
Okay.
Oh, steeper.
Basically,
My
the shape that
bad.
they're doing is something like this. Position time. In other words, it's going in the negative direction, that's downhill.
You better
and reading
step
left, right.
off.
But it's getting steeper and steeper as it goes downhill.
In
Something like that. Try and
negative
sketch that in next to letter D.
direction.
11.2, here's the new part. In this activity, we're going to examine the motion diagrams tried in the previous activity. What do you have to do to velocity arrow 1 to get velocity arrow 2? So I'm looking at the pictures. Here's V1, here's V2. What do I have to do to velocity arrow 1 to make it look like this? What change has happened to V1 in order to make it look like V2? What? Double the length? Okay, perhaps double. At least it's longer, right? So I'm going to have to make it longer. You might say also that you're stretching it, I guess, right? If we actually had an arrow made out of clay or something like that, we could stretch it out a little bit farther than it would look like V2. Which direction
Right.
To the right? I agree. And how much? Well, again, Roger said about double, we're adding about as much as we did before.
Oh, good.
Here's the new thing. One way to show the difference between velocity arrows are called delta V arrows or change in velocity arrows.
That's music.
You can line them up and compare the size of the arrows in order to determine the change.
It's a fun day.
These arrows tell us the direction and the magnitude or size of the change. A complete motion diagram includes delta V arrows. So I'm going to draw the picture that you already have. Try and get the basic idea.
Say hi.
One. Two.
That's my nigga over there. Oh, my nigga.
Three. And I didn't put myself in space. 3, 4. What I need to do is right below the picture of V2, or right above, whichever you want. Your numbers are above, so I want you to, on your picture, I want you to take the length of V1 and copy it over right below V2. I'm going to make a copy of V1 down here. Try and get that same distance. And this one dot to the next dot, you want to copy that down here. Yeah, I expect you to use your fingers. You have them.
Fingers.
You use your pen. Figure out how long it is along your pen.
It's that big.
Okay, there you go. So I want you to copy over V1
enjoyed a
below
lot.
V2. Then what I want you to do is copy over V2 to below V3. Again, dot, dot. So I made a copy of V1 below V2. I made a copy of V2 below V3. I'm going to make a copy of V3 below V4.
We have to watch this later. I can't be your friend. I can't be.
Okay? What? You don't think I did very good? And is there V5?
How you doing?
Now, here's one more thing. That paragraph there said we're going to do something called a change in velocity, a delta V arrow. I don't have those on the picture yet. Here's where they're going to go. My first delta V arrow is going to go from the end of V1 to the end of V2. Okay? So you copied V1 right below V2. How much longer does it have to go to be as long as V2? You copied V2 below V3. How much longer does it have to go to be as long as V3? That is the change
Let
in
me get these
velocity.
paper out.
So the velocity has to change by this much. Velocity has to change by this much. Sorry, I've run out of board
This
space
looks like
here. Velocity would have to change again. So at the end of each of your pictures, you should have little delta V's. And for each one, make sure you do one for the last one too. I don't have room on the board to draw mine. Don't go past the last one. Make sure you're ending at the last dot. I guess there isn't a last dot. The last dot.
There, last dot.
And there.
No.
Mr. Brown,
Yes.
can I have
take them to electric reactive, please.
Okay?
Thank you.
I'm back.
Can I give you the worksheet then?
What?
I'll give you the worksheet.
I'm coming back.
Oh, you're back?
Yeah.
During this hour?
Probably.
Probably. I'll give you the worksheet. Okay.